Good morning and welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or one of the 50% of the people watching who have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a link to Super Chat that runs alongside the show while it is live, and most importantly, if you would like to join the debate, there is a link in the info box below this video. Simply click on mute on the page you are currently watching, then click the link below this video to join the debate and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number one, please do not swear. If you do, you will be ejected. If you are ejected, however, you will be warmly welcome back on the next stream, so please don't try to rejoin the show using sock accounts. With that, I'm going to transition across to my photograph so I can share the show on social media, and I would encourage anybody who is currently in the live stream to please also do the same. Please share the show on social media. Once more, if you're new to the channel or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. We've been joined by our first guest. How are you doing? Make 4, pleased to have you here. If you're trying to figure out how to unmute, if you're on a computer, you need to wave your mouse over the Hangout page and then click mute on the bottom of the Hangout. Or if you're on a mobile device, tap the screen and it'll, there you go. How are you doing? You were there and then you've muted yourself again. We will get there. I assume this is your first time in a Hangout. So yeah, if you're on a phone, just tap the screen and it'll show the mute button and then unmute.
Hey, yeah, I'm also getting a bit of a double audio.
Okay, so the page that you joined from, that you were watching me on, you just need to mute that page.
All right, that should be good, hopefully.
Excellent. Well, you're the first one in. Mike's all yours.
I actually don't really want to say anything.
Okay, fair enough.
Because I'm on the fence, that's all.
I see. So you're here to sort of add input when other people are presenting their views and maybe ask questions and such. Fair
Sorry,
enough.
I just shut my door. Sorry, what did you say?
I said you're just here to ask a few questions from various people on either side of the fence as and when they're in the debate. Is that what you...
Pretty much, yeah, pretty much.
That's fair enough. Good place to be, I would say. I will do a few shout outs. So, I am Face. Good to see you. Technically the first one here. Literally got off IPS's channel, so as I had everything all set up and ready, doing Flat Earth Network as it's now known, I thought I'll just start the hangout straight after. Why not? It's an hour early, as hour early than advertised, but hey ho.
Yeah. So, whereabouts are you exactly?
In terms of Flat Earth and Globe Earth.
I mean, like situated, like what country?
Oh right, I'm in Warwickshire in the UK.
Okay, okay, cool. What's the
How about
time
you?
there now?
It is 10 past 10, which is coming up to. How about you? Whereabouts are you?
I'm in Australia, like sort of southeast Australia, I guess you could say, and it's 9 o'clock.
9 a.m.
Sorry, 9 p.m.
9 p.m. Cool. Oh, that's a pretty good time. So you finish work, plenty of time, relaxed, had your tea. Excellent.
Yeah, more or less. I just like, what kind of people are you expecting? Do you have certain groups of people that come here every night, or apart from trolls, of course?
I don't know, trolls are just people, you know. Yeah, I know what you mean, but there's not a consistent person that comes in. Curved Waters accused of coming in all the time, but I have to point out to people he's not in every debate, far from it. He just comes in when something interests him, like most people. But no, I expect there to be a Flat Earther or Globe Earther who will join next and express their views until someone gets annoyed and comes and challenges them. That's usually the way it works. So yesterday it was Arwin. He joined and explained how he believed the Earth is flat until Flat Earth Math Charles joined, who is a staunch globe believer, and they went back and forth pretty much the entire debate.
That's good. That's good. It's interesting to listen to, but sometimes it just gets a little bit like wild, sort of off topic, and it gets a bit rantish sometimes.
Yeah, I totally agree. That's why I chose to keep these to 2 hours. So now it's the calm before the storm. And then when a Flat Earther or Globe Earther joins, it'll be very calm and they'll explain their point of view. And then somebody else will join who's on the opposing side, and it'll be relatively calm for the first 10 or 15 minutes. Then, about an hour into the show, it'll start to get heated. Then a few more people will pile in the argument, and by the end of the 2 hours, it normally pretty much has descended into chaos by that point, which is normally the best time to end the show.
Do you ever get any other ones like I don't know? There's so many different theories, really, aren't there? Like the concave and the hollow. Like, do you ever get those guys come in here?
Yep, so Cathexis came in and played devil's advocate for concave Earth, as he knows the arguments quite well, or very well. So he put forward the concave theory a couple of nights ago. He was literally just trolling. However, I don't mind, because he put forward a lot of their arguments in a concise way. Doesn't matter if he's taken the mickey or not. He put them forward and people got to hear them, and they, it might resonate with somebody. Concave Earth doesn't resonate with me. It resonates with me about as much as the heliocentric model does. But that's neither here nor there. It's just nice to have that put across. I dropped into the conversation about hollow Earth, which is subtly different. Well, very different, but yeah. So yeah, there's been a few other different theories that have been or have cropped up on the show.
Yeah. See, I mean, I've been sort of looking into it for like 3 years or something, and I can't get to the 100% belief of flat Earth. I guess it's because NASA has like just about everything covered, really, with little, equations and whatnot. I guess really, but it's the one thing that's killing me is like, I was pretty much just about there But what was it? Someone was showing me videos. So I was looking at videos on YouTube, and it was just people zooming into the sun, like from far away, and like even looking at it with the telescope sort of thing. And it's like it does to me. It looks like it goes over that horizon, but but I don't know. Like it's how can we really tell? Sometimes it's just too. I don't know. The distortion and everything. It's weird.
Yeah, I mean, you've got to have an observable, measurable, repeatable curvature for it to go over in the first instance. And so far, what I've been presented with, again, on some of it, even on this show, on the debates, is not that. It's not repeatable curvature. It's curvature that comes and goes with atmospheric conditions. And to my observations, it seems flat. And from what people are doing with their zooming cameras and telescopes, as you put it, is demonstrating that it's flat. And occasionally they'll demonstrate that you can display what appears to be curvature, but it's certainly not consistent and repeatable. And boats occasionally having their hulls obscured isn't a measurable, repeatable curvature in my mind.
Yeah. Like I've seen the P900 zooming in on the sun at a beach or something like that, and it does like as it zooms in, the sun does sort of look like it goes back up into the sky, and it's like what the hell, like yeah. But and also like the other thing that's weird is that whether or not I haven't really looked into this part actually, the equations and the formula sums whatever it is for working out the curvature of the drop, like the 8 inches, and then it's by whatever it is squared. Um, that drop is like really not visible at all, like that. But the problem there is I haven't actually looked into how they do that very well. So I mean, it's if that formula is true, the drop's just not there at all.
Yeah, I mean, it's an interesting conversation yesterday between Flat Earth Math and Arwin, because Flat Earth Math was saying that you only need to use that measure and work it into a different measurement when you're trying to figure out the obstruction, and you're like, okay, so when you get into the nitty gritty detail of it, you're saying it's not to be used as advertised. And Arwin's argument was, well, that's what they tell us it is. So for you to say that I need to fudge it in some way to actually be able to see what you're telling me should be there and obvious, I don't buy it. That was Arwin's argument, and I've got to admit, it was very compelling. And you had lots of a very well versed heliocentric believer, Charles, Flat Earth Math, stuttering away and struggling to overcome some of the arguments that Arwin put forward. And you think, wow, that's not what I was expecting, because Arwin's considered a bit kooky. He's got some pretty way out there views. But when it came to him just straight out debating flat Earth based on the merits, he did exceptionally well.
See, yeah, you have to be quite knowledgeable to go up against, some of these people, really, and you got to be prepared and really on the spot. Like me right now, I'm even freezing up, just like there. But like it's just some of these guys have really got it, and even when it's both sides, it's flat or globe, like both sides will just throw something back at you that just makes you have that second guess like mentality of like confusion, and it just messes with you enough to just be put off, sort of thing, and just be like, oh yeah, but we do kind of spin and we rotate and the sun goes by and like this and that. Oh yeah, okay, like, and then I feel you just get pushed to both sides, like.
Yeah, Shell Scanner, who's in at the chat at the moment, I've been watching a few more of his videos, and he did a series of sock puppet debates and just boiled down the arguments to the most simplistic version, the most concise version, like one sentence. So he'd have one sock say, I believe the Earth is flat because of water. And then the glober would say, I believe the Earth is a globe because of NASA. And then the sock would go, what? The other sock would go, what? Yeah, that sums it up nicely. Well,
pretty much. That's what I feel like a lot of the time.
I believe it's a globe because of the sunrise. I believe it's flat because of the Bible. What? What?
Well, the Bible even goes another step. That's when I start freaking out. I honestly just, I don't know what to go for anymore. I'm even, I might start looking into concave. I don't know, because I don't know.
Concave's nice and easy to wrap your head around. It's basically the heliocentric system and with everything inverted and reversed, so it's pretty quick to wrap your head around it. Once you've got the concept of the celestial sphere being at the centre inside the globe, that's the only bit that you have to wrap your head around. And LSC has got some really cracking models for that, so you can just see it. How he visualizes it, how it's conceptualized rather. But yeah, so get into it. We have been joined by Sleeping Warrior. Very pleased to have you here.
Morning, Nathan.
Good morning. I can finally go on mute.
Where's Curved? Is he late for work today?
Oh, is it you who said that from the chat?
No, I saw it in chat and I thought it was a great line.
I thought that was a good line.
Credit to the guy that said that.
He'll be here soon. He'll be docked some pay for this.
So the gent that's with you, sorry, I didn't catch your name. I've literally only just turned on. Make 4. Are we fellow flat earthers, or are you on the ball side?
I'm like, I'm this like. Basically, I've been looking into flat Earth for like 3 years, I'd say, and I'm like setting out to debunk it, I guess you could say, because I've always been growing up with NASA stuff. But the more and more I look at it, I'm just like, okay, this is weird.
Yeah. Well, let me run something by you, and I'm not doing this to try and catch you. I'm doing this because I've been questioned on it myself. So I'll put my cards on the table for this hangout. I'm only coming on to test a theory, test a suggestion that I'm being challenged on. And you're in the same position as me with regards to your challenging stuff, which is cool. It makes us we're common friends as well as common enemies. Because I kind of want to know what the situation is before I respond officially. Excuse me.
For sure.
We're supposed to live on a ball that's got, we've all seen this segment where they cut out the big slice of the cake and they show the core of the earth with like the inner core, the outer core, and then the mantle, and then you have the crust, and then we live on the surface right on the very, very top. Now, obviously, flat earthers are well familiar with the deepest drill hole that's ever been drilled is the Kola Bore mine in Russia somewhere, and it's only 8 miles deep, 10 or 11 kilometers deep, whatever the maths is. So our position is that what is the empirical evidence to show that there is in fact a mantle or a crust or a core or whatever? Because what goes below 8 miles, we haven't got any empirical evidence for it. It all kind of starts at pseudoscience from that point on. That's the flat earth position. But obviously the ball earth position is, well, if you were to cut a section out of the earth, we have the core, and then we have the inner core, the outer core, the mantle. So if there's a core there on the model, they tell us that model is they tell us that core is made of iron, and that iron is hot, and they calculate excuse me, they calculate the temperature of the core at something like 2000 degrees. It's a ridiculously high amount of temperature. But then this is where I get into the point where I'm like, okay, so we've got a molten iron core. No, it's solid. What do you mean salted? I thought you said it was molten. You mean when we all know what happens with iron? You heat it up, it starts to glow, and then it liquefies at some point, and then you can pour it into molds and whatever. And if you look at the melting point of iron compared to what they tell us the core temperature is, it conflicts with the idea of it being a solid core, because it's that high. Really, it should be a gas because it should have evaporated. But they tell us it's a solid core, but it's that hot that it defies the melting point and the boiling point of iron. So that's a bit of a contradiction for me, which I'm sure there's an alternative answer for. But I just want to push the point forward a little bit to make a couple more points that is really the nuggets of it. Iron as a Curie temperature, all magnetic temperature. All magnetic metals have something called the Curie point. And it's the temperature. It's the point in which the temperature rises to the point where it concedes its magnetism. So iron can be magnetic, but the Curie temperature of it is 1400 degrees Fahrenheit. So above that temperature, it's not magnetic. It does have something called induced magnetism. But when you look it up on Wikipedia, it was either induced or inducted magnetism. When you look it up on Wikipedia, it talks purely about electrics. It talks about currents and power and stuff like that. But the problem is, it conflicts with the idea that there's a Curie temperature of iron at 1400 degrees, and obviously the core temperature is 2000 odd. Sorry, 10,000 odd, not 10. So at 10,000 degrees, aside from the fact that it shouldn't be a solid, it should be a gas. It loses its magnetic effects. Its magnetic properties drop at 10% of the temperature they tell us it is, which then means me to think, well, it can't be solid because it should be a gas at that temperature. It can't be magnetic because it's lost it. The Curie temperature was like 10% of the temperature it's at. The only thing that it's left with is inductive magnetism that might possibly be the core that they tell us is the magnetism, and that's how we get our magnetic fields. But when you look into the idea of inducted or induced magnetism, it requires a current. It can't be done. It's an external force that may well be there, but if it is there, it requires electricity for it to work. So if there is a core there, be it gas, solid, or liquid, and they tell us it's solid, but I don't accept that, it must be a gas, but they say it's solid. If there is a core there, for it to be magnetic, it has to have electricity to it, because that's what their model says. So if let's say it does have electricity there, the electricity's got to be coming from somewhere. Something's creating the current or the power to be able to go down into the core, to create the circuit, to give it the magnetism it requires, because that's what their model says. So on that basis, there is, I'll give you that there's a magnetic effect at the core of the Earth, and I'll give you that, I'll just concede that the core is gas. I'll concede that the core is solid. Even though everything in my body tells me it should be a gas, I'll concede that it's solid, just so that we can have the discussion. Where does the current come from to give it the electromagnetic properties that the induced magnetism requires, because the Curie point has been exceeded 10% of its temperature ago? So we then come to the point where let's just give them that there's a current, which their model doesn't even address. There is no heliocentric model, or there is no, I'm sure Curved would come back at me and say it's not a heliocentric issue, but there is no globular model that addresses.
Isn't it already in the electrons and the neutrons and the protons and stuff, like the magical nuclear force that holds it all together, that they don't really know anything about?
The amount of energy that's required to create the electromagnetism of the core is gargantuan. Because we know that it must be gargantuan, because we know that when we were drilling down to 8 miles, that one of the main reasons why they stopped drilling was because of the heat. So we know that there is a lot of heat down there. And I agree that there must be heat down there, because generally it's accepted that there is. But if there is some kind of circuitry going on, like if there is a flow of electricity, the byproduct of any circuit is heat. So if there is a lot of heat down there, let's concede that the core can be gas, even though it's supposed to be solid. Let's concede that. And let's concede that there is some external force that's powering it, because that's what's required on their model that they don't talk about. So, and let's concede that there is heat down there. We know there is heat down there. When you start digging, it gets hot. That indicates that there is something going on down there to do with electricity. Where is it coming from? Now, this is where it starts getting really, in their eyes, it would be conspiratard, because Tesla
just before you theorize, sorry Anthony, just before you theorize, can I just introduce Physics Warrior? Hi Physics, how you doing? Can you hear us? Have you stepped away? There you
I'm here, Nathan.
Good to have you here. Sorry Anthony, I just want to come off camera and stop interrupting with my kid making noise. So yeah, good to have you here, okay. Physics Warrior, thanks for being here. Sorry Anthony, you carry on.
All right, go ahead.
So then we get into the point where, well, if there is a circuit going on, because we do see the evidence that there's a lot of heat down there, be it the mantle or the core or whatever's down there, that heat that's there is evidence supporting a huge amount of electricity that's being created or is part of an electric circuit of some kind. The evidence is there for that. So then you have to ask the question, well, what's the circuit? If what they tell us is all true, there has to be a circuit, there has to be power. Power's got to be coming from somewhere. Tesla argued that the power was all around us. The electricity, the voltage, the creation of power was all around us. We just needed to harness it. So let's just suppose for a moment that the weather and all that, the lightning strikes and all that, let's just say they're completing the circuit. Let's just say, for the sake of discussion, that up there in the skies is the other part of the circuit, and that the air that we live in is kind of, the way I see it, it's like the gap in the spark plug. So above us,
I see what you're saying. Yeah, like a battery.
More like a spark plug, because
more like a generator, like a
like a dynamo, like a dynamo,
something. I don't know.
Yeah. So it seems that we're living, if what they say is true, it seems that the creation of power that creates the power that's the electricity that's required to generate the electromagnetic field that powers the core that is made of that is solid but should be a gas, but nonetheless that must be powered by something. So is it if the model is correct, it would appear that we are living in the gap between the spark plug. The top part of the sky is the other part of the circuit. We're in the middle, and the gap between the two is the continuous weather supply, which is the continuous lightning. There's always lightning happening somewhere in the earth, right? It might not be where you live, but you can bet your bottom dollar that somebody somewhere is having an electrical storm, which is interesting in itself. They call it an electrical storm or a lightning strike. But somebody somewhere on the earth will be having an electric strike. Which in my head right now, I've got this image. Do you remember the balls, the glass balls that you can touch in the science museums? And as you touch it, your fingers draw the electric towards it, and it looks like you've got magic powers and all that. Well, that's kind of what I'm thinking in my head. So maybe the core of the Earth is the cathode, and maybe the stuff above us is the bit that creates the circuitry and creates and it could be the live or the neutral or the Earth, whichever way around the poles are. I don't know. I'm just following.
Hold on. Is this a flat Earth model?
No. This is the ball Earth model.
Okay.
But my problem is that I've just discussed that there's three issues of discussion there, because the core is told to us to be solid at around 10,000 degrees, and 10,000 degrees is like as hot as the surface of the sun. Now, if you look at the melting point of iron, it becomes a liquid quite low. It's got quite a low melting point, but certainly at 10,000 degrees, it becomes a gas, according to physics. But they tell us it's actually a solid. But for some reason, it defies the laws of liquid dynamics and the solid properties and stuff of melting points and stuff like that. So, but that's a contradiction itself. Secondly, when it loses its temperature, when it loses its magnetism, the Curie temperature is exceeded. The only way that it can hold magnetic properties is if there is an external force. And we know there is a lot of heat down there, but what's the external force that does it? And their model doesn't even tell us about the external force that powers the inductive properties of the core. So there's something powering it if there is a magnetic effect at the core of the Earth. But they don't tell us what the thing that's powering it is, because it is an external supply. You can Google it. Just look it up on Wikipedia, which is what most ball earthers would do. They would start with the Curie temperature, and from there it tells you that once the Curie temperature is exceeded, it loses its magnetism and its inductive magnetism from that point on only. And then you click on inductive magnetism and it takes you into something else, and then you can follow it. But the heliocentric model doesn't tell us that there's an external source. But there has to be if there's going to be an electromagnetic core down there that's creating all this heat and magnetism, of course. So it's kind of missing a piece of the puzzle. But there's a lot of contradictions in what they're saying, because they say that the core of the Earth is what creates the gravity. But it isn't. It has to be an external source that's creating it by applying their own model, which then confuses me, because as I'm a flat earther, I realize that we don't live on a ball. I don't necessarily argue that it's flat. It appears to be flat, but I have evidence that also says from my own observations that indicates that, well, there are times when it appears to be curved. So that doesn't mean it's curved either.
Question for you,
Riley.
Oh,
Riley,
you go,
so
Si.
all right, so just not to go too fast. So your first part is somewhat debunking the gravity with your explanation with electromagnetism.
It's kind of debunking the idea that there's a molten core as well that's spherical in nature, because
that's true. And the second part, you're talking about about where the heat's coming from, or actually where is that source coming from? Now, on the flat side, we are talking about ley lines and nodal points too as well.
yes,
and it's all and then what's on part of the landscape is we're also talking about 75 to 77% saline water, which is also what also provides electricity. And then the third part is you're looking at part is the celestial part of the sky and the celestial bodies. So I'm seeing all those three parts as you are talking along the way. So just please correct me if I'm wrong. I'll just back out of this comment.
No, you're right, and I'm glad that you're still with me, because if you are still with me, it means that I'm not gish galloping and talking rubbish. I'm just telling you that their model is based around a solid, not gaseous, a solid iron core at the temperature of around about 10,000 degrees, which is as hot as the surface of the sun. That they want us to accept it's solid, but in common sense physics, normal physics, it becomes a gas quite low down the temperature range. And at 10,000 degrees, it would be such a dispersed gas because it's so hot and agitated, it probably wouldn't even exist. It would have evaporated. It would have burnt off ages ago and it wouldn't even exist. So for some reason, they want us to accept that it's a core, but it's now become a gas according to physics. And the Curie temperature was exceeded at 10% of the temperature that we're at.
So on the third part, can we safe to say that going up to the highest altitude, it strips out all the from gas? Strips out all the elements from gas to electric charge, and the same as below, which everything gets stripped down from water to actually to electrical charges. So I'm hearing a story. Something did happen with the deep sea expedition that was done. So, I mean, I don't know how to put a link to it, but he found something from the deep sea ocean and bounced up. So 3 days later, he's gone, vanished, or he's dead since after he posted on YouTube.
Can I just also add something to the whole magnetic the pole thing, like polarities? If planets in our globe, Earth, if it was a globe, did have polarities like that, wouldn't that be technically the most attractive points of the sphere? And therefore, like other planets that had polarities as well, we'd all be connected by polarities, and then basically you would only have two sides that there should be planets like coming off of, because that would be the two polarity sides, and they'd all just be connected by polarities or some shit. Like,
this is where we start going into the electromagnetic universe, which the flat Earth model hasn't got to yet. And I'm not saying that there is a flat Earth model, but I'm just saying the flat Earth discussion has not got to the electromagnetic universe. And I'll be honest, it goes way beyond my experience, knowledge, or expertise, because I don't know all the science, physics, and the maths. And it's abundantly clear I'm a retard when it comes to this, because I didn't go down that route in school at all. I went down empirical natured stuff. I didn't go down the physics, literally the subject known as physics. I didn't do that. I went down evidence. So because I didn't do the physics, I don't understand the dynamics that make the conversations, that make the arguments. But by going down the evidence route means that, well, I can tell when someone's not telling me the truth, or I can tell when there's not a strong argument over a strong argument. So I might not know the counter evidence or the counter argument, but I do realize when someone's giving me rubbishy stuff, rubbishy evidence. And the reality of the argument is, I mean, look at the core, the iron core. It's supposed to be solid, but it's got a core temperature of 10,000 degrees. You tell me any product, any element, anything in this earth or on this earth or around this earth, where once you get beyond its melting point, and then you get beyond its you start off at its melting point, then its boiling point, but then once you go beyond the boiling point, you end up with gases that are literally burnt. The gases become that hot and separated. It becomes pressurized, but it doesn't become a solid. But if you keep putting up, unless we live in some kind of pressurized container, we don't live in a pressurized container per se.
I understand what you're saying, man.
Yeah.
That the fact that it's so damn hot down there, it couldn't be a solid. It would just like evaporate, more or less, is one word you said there. So I mean, you go.
So I struggle with the idea that there's a solid core down there in the first place. I struggle with the idea that the temperature is at 10,000 degrees, which is the Curie temperature of the iron that we're told that it is only 1,400 degrees Fahrenheit, but it's 10,000 degrees Fahrenheit, apparently, according to the model. So we're 10 times that. Well, we're 90% beyond, 190% beyond. No, it's nearly 10 times, isn't it? It's nearly 10 times the point of the Curie temperature being exceeded. At that point, iron loses all of its magnetism. So it only has induced magnetism at that point. And once it gets induced magnetism, it relies on an external source to put it in. So it's not impossible that it can receive a magnetic charge or a magnetic field or emit a magnetic field, but it does require an external source. And that external source, when you look into induced magnetism, is electric. So if there's electric being put in, where is that explained on the model? Because it doesn't talk about that at all.
The only thing, like you said, I could suggest is be lightning, more or less.
Yeah. Now I agree. The lightning is there, and I want you to think about the ball where you put your hand over it and it feeds to your fingers and it looks amazing. That would be the only way that I can think this would be working. Now, the problem is the model doesn't cover it. It does not explain this at all, because it doesn't tell you that induced magnetism is required. It requires an external field, an external input. It just it kind of expects you to accept that an solid iron core creates the magnetism and therefore gravity. That's the kind of gap that it wants you to jump to. Now, I'm not saying that that's right. I'm just saying that if you research the Curie temperature of iron, which is supposed to be the core temperature of the Earth, you are forced down a particular route that is inconsistent with heliocentricity. It is not consistent with the idea of a solid core, an electromagnetic field being generated all by itself. It has to be externally applied. And because it's externally applied, it doesn't address where that comes from at all. which then you have to then consider the electromagnetic universe. You're into the Tesla realms. Now, the heliocentric side, or the ball Earth side, doesn't even acknowledge that there's an ether. But there has to be an ether because everyone's talked about the ether. I mean, it goes back way beyond the Sagnac experiments, the Michelson-Morley experiments. They were all tinkering with the arguments for what was moving and stuff, but they were all talking about the ether. Yet ballers these days don't even acknowledge that it exists. Yet it was well accepted long ago that it did. There are people before Christ. If you look on Wikipedia for the history of all the stuff that they were talking about with regards to the astrology of the stars and the ether and all that, you can see it goes back before Christ. But for some reason right now, ballers just say, well, there's no evidence that it exists. Well, there is a preponderance of evidence that it exists, but it's what the form is that is the debate. What form is the ether? What does it do? How does it work? Nobody knows. It's invisible, but it's definitely there because they can detect it and they can prove it to be moving. And it affects gyroscopes. It affects pendulums. You can't get out of flat Earth once you start looking into this particular point, this one point about the molten core of the Earth. Just let me wrap it up back to the point that I was originally making. The guy I'm just trying to see I can't see his symbol. It's OM. The guy that's on mute at the minute, what's his name? I can't see his name until he speaks.
It's Marcus.
Marcus. He was make 4. That's it. Thank you. The point he was making was that he's kind of on the fence with it because he came into it, got interested by it, and then he started to try and debunk it, and now he's not really sure. And I'm in exactly the same place. I don't necessarily subscribe to the idea it's flat because I do have evidence that goes both ways. But I do accept that it's not a ball because there is no evidence to support it being a ball. So just the core, make 4. If you just look into the core, the creation of this core that they tell us is there, that's where you're going to realize that whatever is there, whatever we live on, it's certainly not per model, not per what they tell us. And you can't get past going into the electromagnetic universe arguments, the electromagnetic, and you can't get out of it because it requires an external force. So
it's a turtle.
It's a turtle.
It could be anything. We could be on Halley's Comet. Halley's Comet could be us. I really don't know. But all I'd say is if you're curious about it, Curie, just look at the Curie temperature of iron in relation to the core that they tell us is solid at 10,000 degrees Fahrenheit. It can't be solid at 10,000 degrees Fahrenheit. It has to be a gas, burnt off, dispersed, gone, or it's not iron. Either way, it's wrong. But look into the Curie temperature of the Curie temperature of iron, apply it to the model, and then just see what happens as a
obsidian.
Say again.
Is he just throwing out other
obsidian temperatures?
Oh,
yeah. So I mean, I'm not saying.
Sorry to interrupt. I didn't hear any of that. That last little back exchange I didn't hear. Can Marcus and Physics just repeat what they'd said individually? Maybe Marcus, if you go first.
I had nothing at all. Never mind me.
No worries. Physics, what did you say? Sorry.
No, I just said he's talking about obsidian temperatures, but nothing else. But keep going, Riley.
Well, that was all I was asking. I mean, the original point with Marcus was that he was looking into debate and debunk the flat Earth side, and that's fine. I mean, I encourage and demand that there is evidence to debunk it. I encourage the debate. And
well, it's not like that. I'm trying to be fair to everyone, and really, I do like to hear people's ideas. Like what you're saying to me rings bells. So like, I also would like to sort of ask your opinion of how you feel about things like how there's like 7 elements which are lighter than oxygen, and like how do you feel about those being above oxygen in our atmosphere? Like, does that feel plausible to you? Like, that sounds weird.
I mean, I wasn't. Forgive me. I wasn't asking you to put your gloves up and start fighting me. I wasn't. All I was saying was that you came into it. Yeah, and I'm totally with you with regards to the question of both the flat Earth model, but also mean, look at what they tell us and apply what they tell us to what they tell us and what is realistically possible, because you can't have a gas at 10,000 degrees if its boiling point was like what 800, or if its melting point was 800 degrees or whatever. It's just ridiculous. It's preposterous. That would be my assertion. But if there's some way that can happen and I'm just not familiar with the facts, then maybe, yeah, sure, present them to me, because we're all learning here, right? We're all asking the obvious questions. But with regards to your question about the elements that go into the periodic table that are lighter than oxygen, our atmosphere that we breathe is essentially, they say, 70% nitrogen, and the rest is a combination of stuff, mainly pollution these days, but nonetheless. The elements that go lighter than us are all the elements that are in gaseous form, because they rise above and they will settle in a distillation in a fractional column. They settle above. So you are quite right. But if you've looked into the idea of superfluid helium, superfluid helium is supposed to be lighter than the air that is the helium itself, because the helium is a liquid, and helium as a gas, and helium as a water exist in 3 states, and they've got different masses, got different densities and stuff.
You're right.
But superfluid helium is supposed to be lighter than the air helium, I believe. I might be wrong. Don't stand by this. This is what I understand to be true. It may not be true. I may have got the wrong end of this, but I understand. I've been looking, or years ago, like 2 years ago, I come across the superfluid heliums, and Crow 777 recently. I refound Crow when I found out Brenda deleted all his material, which is a massive foul, and we should all boycott her for that reason. But in any event, Crow 777 was the one that I remember when I was looking into the superfluid helium, because he was the proponent, or he was the protagonist that suggested that there was liquid up there, because he's got the lunar wave, and the liquid could be superfluid helium. Now, I don't know whether that's true or not, but he's got the evidence to suggest that there is something up there that is in liquid state. Now, it's above the gas layers that we live in. So if that is true, it makes the idea that there is some kind of liquid up there. There are other variants, like, for instance, you can have heavy water, and that doesn't appear. There are many variants of heavy water that fit within the periodic table that don't appear on the normal periodic table. That's just one example. But the reality is, yes, right, yeah, there are things that we don't know exist up there, and there is some evidence to support that it's liquid. Now, whether it is liquid or not, I don't know. I tend to buy into the idea that whatever the moon is, be it
I think it could change into some sort of isotope that would seem like a liquid. I mean, whether you call it a liquid is up to you, I guess. Like, what was your name for the what was the superfluid helium? That sounds pretty cool. Let's go with that.
Well, that wasn't my name. I was just repeating the words that Crow 777 uses.
Yeah.
He uses that word a lot, superfluid helium, and it is a thing. I mean, you can look up superfluid helium experiments where you get down to the cryogenic level, where in labs it's like minus 200 degrees Celsius, and they're making. It's weird. You can have in one environment, you can have helium as both a gas, a liquid, and a solid in one environment, and you can have the 3 states. And it's like, how is that possible? And the answer is, I have no idea, but there is evidence that shows it can happen. Now, I'm not saying it's true. I'm just saying that that's what the evidence suggests. But whether that's true or not, it indicates that something else is capable of happening with certain elements in the periodic table when you get down to the cryogenic level, the really cold temperatures. And obviously, none of us are able to recreate that at home with a P900. You know what I mean? I mean, we can't create minus 200 degrees. No matter what we say, the flat earthers cannot do that. We don't have that kind of ability. We just don't have the funding to create the tools, blah, blah, blah. But what I'm saying is there does appear to be something going on up there. And superfluids, really cold superfluids, really can exist in above what we call air. And this is where, if you look into Faraday's disc, I mean, I'm not saying that this is what I buy into. I'm just saying this is a possibility. But if you look at the moon, if we accept that the moon is a tangible object rather than a projection or a reflection or whatever, if it is a tangible object that you can land rockets on, for example, if it's possible that it was magnetic, or sorry, if it was, what's the word I'm looking for? If it was metal in some way, if it was a metal of some kind, which it looks metal. It looks metallic. It's got like a silvery grey sheen to it, and it doesn't look like you can land a rocket on it, in my opinion. But let's just assume for the minute that it is a metallic substance of some kind. The one metallic substance I can think of it most looks similar to is aluminium. It looks like an aluminium disc. Whether it is or not, I don't know. But you can see on YouTube videos the Faraday's disc being demonstrated with huge amounts of current. Now, I'm not saying this is true, but going back to the point where we had with the spark plug and the core temperature and all that, if the moon is a disc and it's kind of aluminium type of metal, you can create an aluminium disc of some weight floating around in circles with current passing through it that will light up lights, and it will literally levitate itself. I don't know whether should I present this to show you it, because I don't know how many people have actually seen this, and most people that
yeah, that's fine, Riley. You're exposing free energy.
Free energy.
Well, yeah, and I mean, like, I'm not
like a superconductor or something. Sorry.
Say that again.
Are you? How does it levitate? Sorry, is what I would like to know.
It requires a lot of voltage, power, and current. I'm not saying that this is true. I'm saying.
Okay, I see how you're doing it. Yeah, yeah, and you're going off just using, say, Earth as a magnet or something.
No, I'm saying.
Sorry.
Let's go back to the beginning, but I'll do it really quick so that I don't labor the point. If there is a solid core and it's got 10,000 degrees worth of Nathan, do you want to present me to everyone so that they can see it?
Yeah, no worries.
If there is a magnetic core and it is 10,000 degrees Fahrenheit, the way they tell us it is, then that Curie point of iron has been long since gone at, like, I think it was 1,400 degrees or something like that. But we're at 10,000 degrees. So the Curie point is gone. It requires an external source to create its magnetic charge, or its magnetic pole that they tell us is the magnetic core, the gravity of the Earth. Now, if that is true, and we see that there is a huge amount of temperature down there when we drill, because we know that it gets hotter, that indicates that there is a huge amount of power down there, because the byproduct of power or of a circuit is heat. We know there's heat down there, so that it does suggest that there is a current of some kind, there is a circuit of some kind. Now, in this, what I'm about to show you will probably blow your head off a little bit. But what I'm about to show you is an explanation for what the moon may be. Now, imagine that the ground is the bottom part of what you see is the Earth that we live on. Imagine that this disc in the middle, which you'll see in a second, is the moon. And this candelabra that he puts on it has got power when he puts it on. When he takes it off, there's no power, but when he puts it on, it's showing that there's electricity flowing through it. This is the visual proof that there is power going through it. And this makes sense for me that the moon could be a metallic object. It may be opaque, it may be thin metal, and it may have holes in it, making it translucent at points or whatever. But essentially, this could be the Earth, and we know it's got some kind of charge to it because they tell us there's an iron core, and it's got a Curie temperature. There's no magnetism. It requires a current. If there is the creation of a current, it means that the moon could exist like a Faraday's disc, which should be here now. It should play. So when this guy starts basically, if the moon is magnetic and it sits above the Earth the way we see it every day, and don't forget, it spins around, it rotates once. But when this guy's putting his candle on, you can see that it's interrupting the current, but it's levitating. Now, levitation, we don't have the skills of levitation in the normal world. But this guy now puts a bit of water on to show how hot it is. So we know that there's a load of temperature below the crust of the Earth, because we know that from the Kola Bore mine, it got hot. We also don't know what the moon is. I tend to buy into the fact that it is magnetic because it looks like it's silvery, like a grey silver color. This example
is the circle ring at the bottom producing the electric current. Where's the current coming from?
Honestly, I don't know. I don't know where the current's coming from. It's using an electromagnet underneath to amplify the current, because when you put a big magnet and then a current through it, it creates a big electromagnet. I don't know what's powering the current. I'm just showing that if there is a lot of power, and the noise that this thing makes is unreal. I don't know if you can hear that, but
yeah, like a high ringing noise.
Yeah, it's a really high ringing noise, and it's loud. Now it's hot, and we know there's a lot of heat down below. And if we're, and when I said like it might be that we live on the gap in between the spark plug and the point where it makes the circuit. We could be living in this gap here, which will be the gap in the spark plug. And if that is the case, then the moon would levitate directly above us, which it appears to do. It could be a metallic disk, which it looks like to me. I would say it probably is. Have you ever heard the argument that the craters on the moon are all facing us? They're not on angles. What's his name? Jake made that point, and he's quite right. But what I noticed with the craters is that they also look like arc welding strikes when you put an arc welder onto something, and it gives you that little explosion of an explosion of the white powder.
Yeah, electrical scarification.
Them craters kind of look like that. So that's more evidence that indicates that it could be electromagnetic, but probably is. It requires to be on their model. But that's evidence that the moon is sat in between the layer of electromagnetic whatever's going on. And this is just demonstrating that not only can the moon levitate on if there is an external force that their model requires, this could be the moon. He's proven that there is a lot of power going through this because it can light up the candle with no power, no wires. I'd encourage people to look into the Faraday effect because Faraday's disk is a visual representation of what we could well be living in if we accept that there is a core at 10,000 degrees that's gone way beyond the Curie effect of iron that is now requiring an external source. And we know that there's a lot of heat down there when we dig. So there is heat to suggest that there's an electromagnetic effect of some kind, but this could be what we're living in. But flat Earth as a topic's not at this point yet. The electromagnetic universe doesn't exist. We're still stuck with, is there any curvature or not? And that's the position I always take. Where's the curve? That's my default position. But I've been presented with an opportunity to discuss flat Earth with a guy that's got 150,000 subs. And when I look on his channel, he's basically an evolutionist biologist kind of guy, and he hasn't got any flat Earth content. And I'm like, what the hell? So this is one of the points that I'm going to be presenting to him that kind of debunks the idea that we live on a globe, because we can't live on a globe if the Curie temperature of of iron has been long since exceeded, and they tell us that there's a magnetic like center of the Earth that creates gravity, because that cannot exist unless there's an external force. So he has to accept there's an external force, which is not explained at all in their model. Otherwise, there is no magnetism, and there is no electromagnetism down there. There is no magnetic effect. There is no fields of magnetism because the Curie temperature applies. You can't get past that. So the reality then becomes, if there is no magnetic effect because the Curie temperature has been met and exceeded like ages ago, that unfortunately means there is no life. Because if you think about how the human heart works, they call it a muscle, but it's actually an electromagnetic pump. It requires electricity to work. Your brain is electricity. Our bodies are fundamentally water, but currents pass through it. And we are electro machines. We require electricity to run. If you remove the electricity out of our body, we die. So if there is no electromagnetism down there, or like magnetic fields down there, without the input of electricity, which has to be there, we can't exist as humans because we need electricity to work. We are part of the circuit. So my position would be on this debate that I'm considering taking would be, well, if we do live on a ball, how can you get past the Curie temperature of iron, being a gas at 10,000 degrees?
Sorry, Anthony, can I just introduce somebody that I don't know? We've been joined by Miles Davis. How you doing? Hello, Miles Davis. Can you say hello?
Hi there. I'm just muting my other channel. Open. There we go. Hi there.
Very pleased to have you, Miles. Good to see you.
I just heard Anthony say something. I'd just like to challenge him on it.
Yeah, you go ahead.
He said that the heart is not a muscle, and he said that it requires electricity to work. Now, that's kind of correct and kind of not correct. The electricity that the body produces in nerve cells is not the same as electricity that passes along wires. It actually is has a very different nature to it.
Sure. I mean, I'll concede the point because I don't know how the heart works. I mean, I'll just give you that point. But all I'm saying is that our body is the synaptic gap in between all the neurons firing that create everything that is like nano-sized technology within our body, or nano-sized biology in our body. the synaptic gap inside the fluid, the transfer of electricity throughout our body, is the proof that our body relies on electricity to work.
No, it's not.
Isn't it running like an
No,
AC
it's not.
current?
The synaptic gap is purely chemical. It involves chemicals traveling from one side to the other and binding to other chemicals, proteins on the other side. And that causes a cascade chemical effect, which causes a depolarization of the membrane of those cells, and allows causes what's called firing, which is really just it's ions moving backwards and forwards across the membrane. It's not an electrical current in the same sense that you get an electrical current on a wire.
Well, the way
it's
it's
more
always
to do with the matter of what's of what chemical it is. Like it's the polarization. They depolarize, don't they, and repolarize or something like that through the heart.
The way it's always shown, or the way I remember it being shown in school, was that it was like the flow of electricity firing between the gaps. Now, if that's if that's a misrepresentation, I'll concede
that's
that.
A simplistic way of looking at it. It's actually, and the picture that's on screen is perfect. You have these little vesicles full of chemical, a neurotransmitter, which is just a chemical, and they fuse with the membrane, pass into the gap, and then bind to a receptor on the opposite side of the synaptic gap. It's a purely chemical thing that goes on. It's not an electrical. It's not a passage of electrons from one point to another.
But would you?
And the heart is just a muscle. I mean, it's not the same kind of muscle as your sort of muscles in your arms and legs, but it is just a muscle.
But Miles, would you agree that every atom requires electricity to exist? Like there is electricity.
No, every atom has electrons,
sure,
but associated with it. Whether you'd say it requires electricity to exist, we're kind of blurring definitions considerably there. Well, this idea of an electromagnetic universe
I would assert that you'd only blur the boundaries if you wanted to blur the boundaries. The way I understand it, atoms.
No, you're blurring the boundaries, not me.
No, you said I'm blurring the boundaries, but I'm saying that I'm not. I'm saying that you're claiming that it's a blur, but what I'm saying is every atom has electrons. So essentially, by definition, it requires electricity of some form. Otherwise, there wouldn't be electrons, neutrons, and stuff.
No, your claim that the whole universe is electromagnetic is.
I didn't say that.
Well, or that it is an electromagnetic universe. I mean, of course, electromagnetism exists within the universe. And everything is inherently interlinked with everything else.
My claim, clear, because I don't know how much you heard. My claim was, if the core of the Earth is an iron core, solid iron core, at a temperature of 10,000 degrees, then the melting point and the boiling point of iron have long been exceeded, and the Curie point has also been exceeded. So we're left with a burnt-off gas, essentially, of iron that they tell us is magnetic. But because the Curie point's been exceeded, the only way that can work is if there is an external force creating the electricity, the magnetism, and the only.
You're making an assertion there without the knowledge to understand. Now, I don't understand how the magnetic field that exists, that everybody can measure and observe, on the Earth. I don't know the details of exactly how that is created, but I understand that physicists do have very good their theories, or hypotheses, I guess, not theories yet.
Okay,
can I finish my point? Because you keep doing this, interrupting people.
Well, you're stuttering. It doesn't sound like you're making a point.
I am making a point, and if you'd shut up, you might hear it.
Okay, well, try not to stutter, because that sounds like it's credible.
If you are going to criticize someone for pausing and trying to find the right words, you've really got a bad attitude.
I'm suggesting you gish galloping.
Shut up and listen for a moment. Thank you. The physicists have some very good hypotheses, as I understand it, for how a molten plus, I think they think that the central part might be solid, how that core can generate a magnetic field. We know that the magnetic field exists. You are making an assertion that there must be some external force, but you're basing that on absolutely nothing other than just
Stop.
I can't see how it could work any other way, so it must be like this.
Let me explain exactly that point. So let me speak now in response to the claim that I'm talking rubbish. I can clearly
I
demonstrate it.
didn't say you were talking rubbish.
What you said was I made an assertion. Right. Do
Yes.
we need to play back what you've just said? Or would you
I
want to repeat?
said you made an assertion. I did not say you were talking rubbish.
Go on. I made an assertion based on absolutely nothing. That sounds like you're saying I'm talking rubbish.
Hey guys,
No, it doesn't.
I'm gonna have to take off.
It's entirely different.
See you, Thigh. Bye bye, psychics.
See you later, pal. Okay, let me show.
I think you guys are both smart, and you both have pretty damn good points. And I think that it's not all 100% electromagnetism, but also like there's matter in there as well, which there's
let me
this hot core thing. My heart electrons are burning up for a cigarette, so I'm just going to be right back.
Sure, no worries, mate. Let me take this moment where I've got the time to speak. Miles, let me go for about 3 minutes, and then you come back to me with where my assertions are based from. If you search for the Curie temperature, we'll use Google to start with because that's what ballers generally use. So when we're criticizing,
I'm not actually looking at your screen, so if you're showing stuff, then I won't see it, but I'll listen to what you've got to say.
All right. So, Nath, could you just present? I think you then should see it. Am I getting a flashing screen?
Yeah, it is flashing for me too.
All right, let me knock that off. Let me try it again. What the hell? Is it flashing
again? Weird.
Right. What on earth? Look, should I jump out and jump back in?
Yeah, it might be an idea. Might solve the
Give me
problem.
I'll be straight back in 1 sec.
Just while Anthony's gone, Miles, I mean, you immediately sort of, when Anthony jumped over you, I think it was because you were stuttering about what they were they're theorizing about the core of Earth. And it is exactly that. I mean, they have no idea what's at the core of Earth.
Let me present very quickly, and here's something that that does provide an explanation. It may not be absolutely true. Can you see my screen?
I can.
The only thing, though, Miles,
can you see my screen?
I want to go back to the point that you made that I'm making it without any assertion, without any
presenting
basic.
Sleepy Warrior at the moment. He just wants to get through his point that he just started before he dropped, Miles. If you can just let him get through, and then if you want to go through your points.
Yeah, that's fair. Let me address why my assertions aren't based on nothingness, because that otherwise we'll not get back to it, and then your statement will stand, and people will think that my assertions are based on nothing, and that wouldn't be fair on me.
If you're going to talk about the Earth's core and the Earth's magnetic field, I did not say that that was based on nothing.
No, you said that my
your claim. I said that the statement that there is that the universe is an electromagnetic universe is based on pretty much nothing.
Well, let me demonstrate how that's not the case. So just shut up a minute and let me present my point. Nate, you want to present me? Right. So the Curie temperature of iron. You can look this up in direct relation.
Yes. I know what the Curie point is. Yep.
I'm not talking to you at this point, Miles.
Okay.
I'm just talking to the audience. So just shush for a minute and let me speak. The Curie temperature is the point where it's the temperature at which certain materials lose their permanent magnetic properties to be replaced by induced magnetism. Okay, so applying it to iron, it loses its permanent magnetic properties at the Curie temperature. Now it gets replaced by induced magnetism. And when you click the link into induced magnetism, it says induced magnetism is the vector field, which is basically arrows on a drawing, that expresses the density, we all know what density means, of permanent or induced magnetic dipole moments in magnetic material. The origin of magnetic moments responsible for magnetism can be either microscopic electric currents. Now that's not talked about on the ball Earth model at all, because it's not credited in any way, resulting from the motion of electrons in our atoms, or the spin of electrons, or the nuclei. Net magnetization results from the response of a material to an external magnetic field. Now, if the Curie, this is where the assertion that's based on nothing comes from, Miles, because if the Curie temperature is met with iron, then this applies. And it clearly says net magnetization results from the response of a material to an external magnetic field. It's external, it's not internal the way we're talking.
No, that's net magnetization. That's not a material producing a magnetic field. You're misunderstanding what's being
No.
said there.
Do we agree that when the Curie temperature is met, that the iron loses its magnetism?
It can lose its own magnetism,
No,
yes,
it does.
but that's not the same as it not being able to generate a magnetic field.
Okay.
Can I be presented?
Wait,
and
wait,
so I
hang
can
on,
just
hang on, hang
explain
on. Just wait.
the current. Can I explain the current thinking so that we can get the current
No, not yet.
explanation of because you're misrepresenting the ball Earth model.
Hang on,
and
you're
you
claiming I'm
present-
misrepresenting, and I'm still explaining. Let me finish explaining, and then you can say why it's
Well,
wrong.
Okay, carry on. You talk away.
So the Curie temperature has been met. The iron has lost its magnetism because it's become a liquid. Okay, it goes beyond the point where it becomes. It may not be in liquid state at this point, but it's definitely lost its magnetism because that's what the Curie temperature is. So at that point, you've got iron that's got no magnetism. So when you go beyond that point and it's got no magnetism, it clearly says that magnetization results from the response of a material to an external magnetic field.
Yes, that's magnetization. That's not it being able to generate a magnetic field. Now, if you'd allow me to present, I can explain to you. I can explain to you how the Earth's core is believed to create a magnetic field.
I give way.
Okay, is my screen being seen? Can someone present me?
Yep, you're presented.
Okay, so I just very quickly typed what causes the Earth's magnetic field and went to one of the first results that I got, and this gives the theory of how a theory or a hypothesis of how the core creates a magnetic field. Okay, so there's a solid inner core, 2/3 the size of the moon, and composed primarily of iron at a 5,700 degree temperature is what is believed, and it's being compressed obviously by gravity, and that prevents it from becoming liquid. Surrounding that core, there is another layer of iron, nickel, and small quantities of other metals, and the lower pressure, because it's further away from the center, means that the metal here is fluid. Differences in temperature, pressure, and composition within the outer core cause convection currents in the molten metal. As cool, dense matter sinks while warm, less dense matter rises. The Coriolis force resulting from the Earth's spin also causes swirling whirlpools. This flow of liquid iron generates electric currents, which in turn produce magnetic fields. And so that is the idea behind the core, even though it's very hot, producing a magnetic field. It's not doing it in response to any external force, i.e. something coming from outside the Earth. It's to do with the effects of gravity and pressure and the spin of the Earth, and that creates a magnetic field. Now that may or may not be perfectly accurately true, but I would believe, and I'm sure that it could be researched and checked. The physicists don't come up with these kinds of explanations just off the top of their head.
Yeah, they do.
Based
that's
on
exactly what they do.
A large number of studies and investigations that help to confirm this sort of thing.
This belief.
Is there any evidence for an
belief.
external force generating
It's
that
just a
magnetic
belief.
field?
It's just a belief, Miles.
Hang on, stop.
No. To say it's a belief means it's just something that somebody's plucked out of the sky and said that I believe this.
That's correct. That's what a belief is.
Physicists have done is it's far more involved than that, and I'm sure if anybody was to bother to go to research that, you'd be able to find out the reasons for them coming up with such a hypothesis.
So it's a very complicated belief. Well, it's still a belief.
Can you please put that back on screen and let me respond?
It's an explanation.
Right, can I respond? Yep. The opening line states that our planet's magnetic field is believed to be generated deep within the Earth's core.
Yes.
Okay. The word there is believed.
Yes.
Did you read that word, Miles? The word belief?
Yes. But to believe something is not it has multiple meanings, and belief belief is often used in a sort of religious sense, if you like.
Yeah, that's right.
Which
in a religious sense,
which
like
means I
like
believe
believing in
something
God and things like that.
regardless of the facts or regardless of any evidence that might be presented. So people believe in fairies, for
Miles,
example, even
stop.
though there's no evidence. To believe something is different to I believe that if I eat food, I will continue to live. That's not a
Miles,
belief
stop.
based on no evidence.
Yeah,
Miles,
people
stop.
believe there's an hold on, Anthony. People believe there's an oversized iron core because they also believe a planet called Theia smashed into Earth long before we have any records of this happening. So it's all based on belief. There is no two ways about this.
That idea is, and other ideas are based on evidence. So, for example, by measuring the sound waves that travel through the Earth as a result of earthquakes and so on, you can get some evidence for what is actually lying internally within the Earth. So the idea that there's an iron core down there is, and there's nickel and other things, is not simply based on a belief that something happened millions of or billions of years ago. It is based on evidence that can be obtained today.
Miles, stop. I'll give way on the belief bit, but I wanted to put the context in that our planet's magnetic field is believed to be. I'll concede that a belief can be somehow a fact, but you said it was based on evidence. I've given you the evidence of the Curie temperature of iron being exceeded by, it was 10% of the temperature. That it was 2,000 degrees is what they claim is the inner core temperature.
And this is accepting that. And still coming up with a perfectly reasonable and factual explanation for how a magnetic field can still be generated.
Wait. But then I showed you that when you go into the Curie temperature and then you click the link that it takes you to, it requires an external source for it to work. That's evidence.
No, it doesn't.
So do we need to
requires an external source for that material to become?
Please stop speaking over me. I'm trying to respond nicely. Do I need to represent that point because I think you might have missed it? It showed clearly that it requires an.
I understand it.
But it said specifically it requires an external source.
And in this case, the by external, they mean something that it doesn't necessarily mean that it has to come from outside the object itself. The external force in this case is the effects of gravity and pressure and the Earth's spin on the core.
But
that is what generates the electric currents. That is what and the electric currents generate the magnetic field.
But it says clearly external source.
Yes,
and you're describing stuff that's internal.
No, and this is where I say you're misrepresenting. The fact that it is external means it is not purely to do with the property of that material itself. Okay, the external force is the gravity. It is the pressure difference is caused by the gravity, and the heat difference is caused by convection currents and so on.
Do you have a citation for that, Miles? Do you have a citation for that at all?
Sorry?
Can you cite that? Can you provide a citation? That just sounds like a load of words to me that you've just gish-galloped.
Not right now, but there are.
It's just gish-gallop then, nonsense.
It wouldn't be too difficult to.
Well, do it then.
To research that yourself.
Well, off you go.
It's pretty straightforward.
It seems like you're redefining the word external, Miles.
Sorry?
You're redefining the word external and then saying, I'm sure you could prove it.
No, I'm not.
That's exactly what you've done. You've just tried to redefine the word external.
No, I did not. Anthony is claiming that the word external means from outside the Earth. I am saying that the word external there simply means external to the material itself. So if you had a magnet and you heated it up, then in order to the point that it lost its magnetism, in order to make it magnetic again, you would need to provide something external to that magnet, that small magnet.
Yeah.
In the case of the Earth, what you're dealing with is a huge body which has forces of gravity and is also spinning, creating other forces, which those forces are acting upon that heated magnet, effectively, or that heated magnetic material, and those forces cause the convection currents that create the magnetic field. There's no
Yeah, but what creates the convection, though,
and
Mark?
I'm
Stop.
perfectly happy to accept that is only one possible explanation, and it
Hang on.
might well be that there's some magic explanation that also does it. But
Just
what
hang on a
I've
sec.
yet to see is any evidence for some magic explanation, and this seems to be based on evidence that can be verified. Okay, I haven't got links to the papers or other references citing this, but this is.
How do we verify the core of the Earth? This is what we're talking
generally
about.
told
How do we verify the core of the Earth, Miles? You tell me how I verify that.
Okay, if you want to do it yourself, you would need to actually get involved with a team of physicists and seismologists and geologists and actually do the experiments where when an earthquake happens on one side of one part of the Earth, there are stations all over the globe that measure the sound waves and the energy that comes from that earthquake, and by doing some complicated science on it, you can gain an idea of what the composition of the Earth must be in between. That
would be
the core of the Earth and the mantle and so on.
So what you're saying is
we have a good idea what
we
is below
take
the
measurements
crust,
from the
because sometimes
outside,
it leaks out.
Miles.
You
We
know,
take
but there are
measurements from
people
the
who study
outside.
this.
Is that what you're saying? We take measurements from the external to extrapolate what is on the inside. Is that what you're saying?
No, the earthquake happens at the crust. But
Well,
but
you assume that.
and the effects of that earthquake travel through the Earth and can be measured in other points on the Earth. And by looking at those measurements, it's perfectly possible to make some educated guesses. Yes, they're still guesses. No scientist would claim that they know exactly what is in the core of the Earth and exactly how it behaves.
Miles. So what you're saying is it's a guess.
No,
And a
I'm
belief.
not saying it's a
And a
guess.
belief.
A guess implies that.
Well, I've asked for
you
verification,
have
Miles.
no
I've said,
evidence
how
on
do
which
I
to base
verify
it.
that is what's at the centre of the Earth? And you've told me we have a little guess. So good answer.
I
Thank you
didn't
very
say
much.
that. What I said was you make
Educated guess. Yes, nice.
with
Educated guess. Jolly good.
Lots of data to back it up. Now you could say that there is marshmallow in the centre of the Earth, right?
No, that's not my point.
So that would be a guess. And maybe there is marshmallow at the centre of the Earth. I can't prove to you that there isn't.
Maybe there's a molten iron core. Maybe there isn't.
What-
We just have to have an
what
educated
scientists
guess.
do-
Maybe there isn't. Maybe there isn't an iron core.
Is they look at what evidence they have and they try and design tests and measurements and experiments to gain more information.
Maybe you missed my question,
And
Miles.
what
Maybe
they
you missed my
find out
question.
is that all of
I'll
that
repeat my
data
question just once more.
agrees with
Just once more, Miles,
what-
for you. How do we verify this? Not educated guess, not
okay,
extrapolation,
so
verification. Do you understand what a verification is?
I know what you're saying. So what you want?
I want you to say, Miles, that we can't verify it, but you won't. But I want you to.
No, I'm not going to say we can't verify it.
But we can't verify it. That's a fact. We can't.
We can do.
Oh, tell me how.
Go and do some physics.
That's the
we're
nonsense
trying to
gish gallop
physics, but you're
answer.
not
Do you want to tell me how we verify it? Or do you just want to tell me how we extrapolate an answer and guess?
It's not okay. Let's. You at the moment are guessing that I am a person sitting at a computer or some other device on the internet. I might not be. Okay, I might be a complete figment of your imagination at the moment. Okay, and you can't verify that I'm a person sitting at a computer talking to you over the internet. It is impossible for you to verify that according to your criteria. Now,
no, it isn't.
You would
absolutely
argue,
not.
I would
It's
hope,
absolutely
that there is
possible
good
for me
reason
to verify that
believe
you
I am a
exist.
person.
That's nonsense. I can verify that.
Link.
I can verify that you are a person. I can travel
No,
to
you
you.
can't.
Yes, that's
It's
nonsense.
kind of coming to a bit of a
No,
dead
you
end.
absolutely can't.
Yes, I can.
Right, listen,
Well,
we're on a
then do it.
tangent that's useless. Let me
Okay,
it.
I concede.
Do it.
You have the mic.
Verify
Anthony.
that I'm a person right now.
Right. Right. We're on a tangent that's useless to the topic we're talking about. Let's go back.
No, it's not, because this is the kind of nonsense that you
Stop
guys come
talking
out
over
with.
me.
You
Let me
can't verify it. You can't do this. You can't do that. When all the evidence points in one direction, you like to claim that it can't be verified or it can't be proved. Therefore, everything else is equally valid, and that is
Stop.
nonsense.
Miles, stop. Let's go back to the point where you said that about convection currents create electricity. Do we agree do you know the first law of physics, the first law of thermodynamics?
Mm-hmm.
Do you want to recite it? I know this is off the top of your head, and I don't expect you to.
No, I don't particularly want to recite it.
All right. The first law of thermodynamics.
On any error I get.
No, just a general. Right. It's the general law of conservation of energy. Right. It states that the total energy of an isolated system in which we live. Do we agree that we live in an isolated system?
No.
We don't.
No.
So all right. So then that's your get out for the first law of energy conservation being fouled, because most people on the heliocentric model claim that we live in a system of isolation.
No, they don't.
They do.
No,
Well,
they don't.
What's the external thing that makes it not isolated then?
The rest of the universe.
We're isolated from it by our own atmosphere, are we not?
No, we're not. The sun energy is constantly entering the Earth system.
Okay,
Constantly.
so would you agree then that the Earth is isolated from it?
No.
If not, really?
Absolutely not.
So you're saying that the conservation of energy law does not apply to Earth?
The conservation of energy applies in a system that is isolated. Okay.
Yeah. But
and if you are going to consider the Earth as an isolated system, you can't, because it is not isolated. There's energy arriving all the time in the form of radiation from the sun.
Okay, I'll concede that point then.
And there is also magnetic effects of the moon, the sun, Jupiter, and so on.
I don't agree with you that we're isolated, that we're not isolated, because I believe that we are isolated by virtue of the fact that we are an Earth with an atmosphere. We are isolated. But if you don't accept that point, I'll move on. I'll concede that point and I'll move on to the convection point you made. The convection currents, are they a consequence of the heat that's being generated, or are they the vehicle that provides the movement that gives the electricity to the heat that's then created? Because one is a consequence, one is a cause. And I assert that when you said that convection currents provide the electricity, that's the external force that's required to magnetize the core, you're saying that that's the cause. I'm saying it's a consequence, and as a consequence, it would lose energy over time. So unless you're going to argue it's a perpetual machine, that its own perpetual dynamo machine, then the convection currents are a consequence and are not feeding the external source that it requires to be magnetized.
The current thinking, as I understand it, and I wouldn't claim to be an expert on any of this stuff, and I'm surprised sometimes by the way that people like yourself ignore what experts actually who study this stuff actually say. But the idea is that the gravity and the pressure generated by gravity, I mean, everything is being pulled into the center, and that creates heat. The heat is part of what creates the convection currents. There is also the rotation of the Earth, which will contribute to that as well. The movement creates electric currents, and those electric currents, by their very nature, an electric current generates a magnetic field.
Yeah, but Miles, listen, which creates which? Is it the heat that creates the convection, which then creates the external source, or is it?
Why do you keep saying external source? There's no external source.
But it's required once the Curie temperature is met.
The Curie temperature, the temperature is isolated, if you like, or is separate from.
You can't claim isolation.
The heat. It's not isolated. I said I changed that to separate. Okay, it's separate from the convection currents and the heat and so on. You're desperate to find some word way of making this a purely internal thing, and then you'll disregard it because you say it must be external.
No, I'm saying that you're cornered with Gish Gallop and you can't get out of it.
No,
You
the
said-
gravity is the gravity, the spin of the Earth, and so on, that create the heat and create the pressure that creates the heat. These are external to the core itself,
But
and that's why it's an external. It's the external force is the energy
Well,
from that external force.
but-
It allows the creation of a magnetic field.
sorry, I didn't realize you were passing me back the mic. I was waiting for you to make a point that was concise, because the reality is you said that the convection currents create the movement of fluids, create the electricity, but you indicated that that was the source of where the electricity comes from. I'm saying that that's the consequence of the heat that's there in the first place, that's
Yes.
receiving an external source.
And that's fair enough. Yeah.
But you're saying that it's the convection currents that feed the electricity into it, and I'm saying that's not true.
No,
That's a
the
consequence.
convection currents are what creates the electric. The flow of the liquid creates the electric currents, and that an electric current will always produce a magnetic field. That's just what
Yes, but
electric
I'm saying
current
it's the consequence. I'm not saying it's the cause, but you've got to argue it's the cause, because once the Curie temperature is met, there requires an external source, which you cited to be convection currents. But I'm saying that's a consequence. It's not the feed. It's the consequence.
It's a consequence of what?
The heat that's being provided by an
Yes,
external
so
source.
I'm saying
Don't
exactly
accept
the
it.
same thing. The heat is there, and that causes convection currents, and that causes electricity, which causes magnetism.
But where does the heat come from?
The heat is a result of the pressure that the core is under from the effects of gravity, and the pressure created by the rest of the Earth being trying to be pulled into the very center. That's how it works.
Yeah, this is where, like, I sort of imagine it as like those more dense, heavier solids which gravity is more attracted to and get pulled in like to the center, would be crushing down on each other, which like masses of weight and heaviness eventually, like once the rock got big enough or whatever, or dust, and then possibly that would be causing like little sorts of like frictions and reactions inside those rocks, which would be tiny bits of electricity, as well as the gases on the outside of the solids also frictioning, if that's not really a very good term,
Yeah.
but also reacting with the solid in a way of friction and touching on the solid, and sort of, you know, getting electricity generated out of that as well, and hot and cold pressures like going up and down as well through the elements would be part of it. But there's so much to it. Like the Curie temperature is weird because you're saying it loses its magnetism after that temperature, but
So we have around 30 minutes left on this live stream, so I'm going to run through my links and then I'll pass you back to the action. So if you are new to this channel, or you are one of the 50% of the people watching this stream right now that are not subscribed, please click on that subscribe button and the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a link to Super Chat that runs alongside the show while it is live. And most importantly, if you would like to join the debate to contest or agree with anything that is currently being said, simply mute the page you are currently watching, then click on the link below this video to join the debate and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number one, please do not swear. If you do, you will be ejected. However, you will be warmly welcomed back on the next stream, so don't try to rejoin the show using sock accounts if you are ejected. If you've not done so already, please share the show on social media, and a massive thank you to all of you who have done exactly that already. Be sure to subscribe.
A fictitious force, but we're talking about, in your own explanation here, we're talking about
Fictitious doesn't mean it doesn't exist.
No, but neither does believe to mean it's a fact, and yours
Correct.
is based on a belief.
Correct.
At this point.
I'm not claiming that this stuff is as well established and as universally accepted as
Okay.
certain other things in science.
Well-
By its very nature, we can't dig down into the Earth far enough to actually find out, exactly what's there. And
Yeah.
tests
But
are better explanations and tests are being done. I mean, physicists do all sorts of things, many of which I don't understand.
all right, Miles.
But they all, everything they do fits. I mean, people design experiments to measure neutrinos and things like that after they've passed through the Earth. I mean, and they would only, these things would only work properly if there was the ideas about the Earth were generally at least accurate, if not specifically accurate.
Okay. Now you've would you mind not sharing? Because I think when I'm trying to share on, I think that flashing results from you sharing when I'm trying to share too.
I can stop sharing. I think there we go. Hang on. Okay, I've just stopped sharing.
It's still flashing though, isn't it? Oh no, is it flashing?
Yeah.
I don't know why
you're sharing, but you're flashing.
You'll have to just persist with this because it's only going to take me 2 minutes to conclude it. So at the moment, your position was based on beliefs and accepted practices that you consider to be the truth, right? And that's fine.
I would dispute the word beliefs.
Well, it said the word belief.
It has a connotation. The word to believe something to be true is rather different than holding a belief.
Okay, but the opening sentence in the page that you cited was the word belief. It is believed to result from the sentence.
It is believed,
okay,
and that is different to holding a belief. I believe that 1 + 1 = 2.
Come on, Miles, wait.
Okay? That is different to holding a belief that there is a fairy at the bottom of my garden.
Miles, stop. Let me finish the point, and then you can come back to me. All right, so yours was based on the opening line said belief, and I know you take issue with the word
belief. It says believed.
Shush. Believed. Okay, believed. Yours is based on the believed position, right? But I can go back to the physics that we can apply, and I can go back to real world experiments and evidences to prove certain points. Now, my position is the Curie temperature of iron when it's in its 10,000 degree Fahrenheit state is long since exceeded. And when you go into looking into the Curie temperature, it clearly states that when it loses its magnetism, it requires an external source because you have to, again, I'm not going to go read through it all again, but it's the point where you click.
And we have established that there can be an external force that creates the Earth's magnetic field without any need for any magic. Okay, it's simply gravity and this rotation of the Earth. And who knows, there may be some other physics involved that is not mentioned in that page that I found.
Miles, stop, because
those are your external forces. You don't need anything else.
Let me finish, because what you're doing is derailing the point I'm making to counter your point, and that's
not
fair.
Come on then, make your point.
Okay, so once the Curie point's met, okay, they lose its permanent magnetic properties, and it's replaced by induced magnetism. We can click on induced magnetism. Good. And in here, it talks about the electronics. Now, you state that it comes from the convection currents and the Coriolis effect and a few other things that you add to that makes it the cause. I'm saying that there's an electronic, an electro force that's external that has to be put into it to create the heat that's resulting in the convection currents that are a consequence, not the cause.
So brilliant. And what is that external?
Well, it's high voltage, lots and lots.
What is it? Where does it come from?
Well, essentially, it's the luminous ether, isn't it? It's the electromagnetic spectrum of the universe. So we start going into the world of Tesla. So if I just put the word Tesla into there and then click image.
So you have nothing.
Hang on.
No source. You have no evidence for any of what you're saying, which was my original point.
So let me try and find a picture of Earth.
But are you trying to prove this on a point that like it doesn't exist and it's actually flat and because are you saying that the ether could be hot enough to somehow transfer electricity into this core and keep it molten or something? Or
what I'm saying is that if we live in this car in the middle, there is an external source that's providing electricity or power that's being put towards the core of the Earth, which would be like the cathode on a battery, the negative on the battery. It's being fed by the outside. That's creating the power that's necessary for the magnetism that your model requires. And the convection current, or the heat that's created, then creates the convection currents, which do feed into it, but they're a consequence. Now, the reality is this. there has to be something that's feeding it, Miles. And I know that you claim it's the convection currents, but I'm saying that they're a consequence. They're not the cause. Something
Okay,
else is feeding it.
but we know that gravity will create pressure, and that pressure creates heat, and that heat creates convection currents, and that convection currents create electricity, which in turn have a magnetic field.
But would you
all of that is known and established, and by vast quantities of evidence. You are claiming that there is some external electromagnetic force out there that applies to everything that you cannot provide any evidence for. You cannot provide any measurement for its extent or its power, but yet you claim it is what is driving this. What in the meantime, ignoring the known forces that we can understand are driving it.
But do you understand, though, that Coriolis effect and gravity are generally principles that flat earthers like myself don't consider to be proven to be factual? They seem to be theories, like relativity is a theory.
Well, a theory is a scientific hypothesis for which all evidence and all measurement and all testing has corroborated, to the point that scientists say we will accept this theory, this hypothesis, as now being true, not proven, but true, until someone comes up with something that shows that it is not true, because it is so much supported by so much evidence, and that applies to germ theory of disease. It applies to evolution theory. It applies to relativity and quantum mechanics and so on. I mean, lots of physicists hate quantum mechanics instinctively, but it works on every single test, so they're happy to work with it.
Miles, I'm just citing from Wikipedia. Why am I getting feedback? I don't know why I'm getting feedback. Can you hear the feedback?
Yeah, can you just pop yourself on mute, Miles, just while you're not talking?
I don't know why it's doing that. I'm just citing from the Wikipedia link, and it says gravity is most accurately described by the general theory of relativity proposed by Einstein, which describes gravity not as a force, but as a consequence of the curvature of space-time caused by the uneven distribution of mass. Absolutely. Are you seriously considering that the heat that's required to power the core that gives the convection currents, which you claim is the core, is the source, and gravity is the thing that makes it happen too? Are you seriously asserting that the curvature of space-time is somehow causing the heat that's required in the core to get it to the 10,000 degrees Fahrenheit? Because if that's your position, my assertion is that's preposterous. I'm not asserting
that.
You said gravity.
I'm not asserting that. I'm saying that is what is observably the case.
But gravity, you said, was the thing that was pulling it all together to create the pressure and all that. But that describes most accurately that it's not a force.
There are different ways of looking at gravity. Now, Newton came up with a theory of gravity, which for all intents and purposes is perfectly okay, but doesn't explain correctly or entirely correctly what happens in very small situations, in very large situations, like in black holes or down at the atomic level, subatomic level. What Einstein's general relativity theory did was to give a slightly different explanation for gravity, which better explained those extreme situations, as well as providing a perfectly valid explanation for the sort of general everyday size and shape of things that we deal with.
Okay, now, Miles, just 1 sec. Just let me just conclude.
There's no discrepancy between the real discrepancy between the Newtonian gravity and the Einsteinian gravity in terms of gravity generating pressure and heat when you have really large, massive objects involved.
All right, but this is the most accurate description of gravity, and it describes it not as a force, but as a consequence of the curvature of space-time, but also it's the weakest of the 4 fundamental forces of physics.
Absolutely, it is, which is why you need hugely massive objects like like, I mean, even in galactic terms, the Earth is not a very big object; it's tiny. But to us, it's a huge, massive object, and therefore although per kilogram, gravity is a very weak force. When you get something that weighs 10 to the 24 kilograms or whatever it is the Earth weighs, then that gravitational force is now much, much larger.
But the thing is, though, Miles, when you add together the beginning part that stated that it was a belief, and then we show that gravity is a theory and it's not that strong, and it's the consequence of bending space-time, but you use that to explain the creation of all the energy and the power that's required to heat that core of our Earth into a solid at 10,000 degrees Fahrenheit when it's supposed to be a gas at that temperature. The Curie temperature's failed, massively been surpassed, and you're explaining that by gravity, and it's kind of... beyond the realms of probability.
No, it's not. You're plucking on the words like weakest force, as if that means that that because it's the weakest of the four forces, it can't be a strong enough force to cause the effect that we see that it does. Your argument from incredulity here, I can't see how that could possibly be true. It must be some weird space magic that I'm going to invent.
You're totally misrepresenting my position. Miles, you're totally misrepresenting my position. What I'm saying is your argument appears to be very, very remote. My argument's based on the...
It's very...
Wait. My argument's based on the application of the Curie temperature, which puts all yours into a really remote, really difficult to prove, and you've given a really weak explanation.
No, the thing that you read out about the Curie temperature proved exactly the point that I was making.
What point were you? No, it didn't prove the point that you're making. The point that you're making is that gravity essentially is what makes all this happen. But I've just given you numerous examples where it's described essentially as theoretical, yet you accept it to be true. Now, if you accept it to be true, I can accept your position. But what I'm saying to you, Miles, is the Curie temperature is real physics that you're applying beliefs to.
And it confirms the way that the Earth's magnetic field is generated.
It confirms your belief. It confirms your belief.
Yes.
No. It's not a belief.
It doesn't confirm any facts, Miles. It confirms your belief.
Now, I accept, Miles, that you've got your beliefs.
Entirely
your beliefs, and that's totally acceptable. But what I'm saying is there are physics of the Curie temperature is something that kind of can't get past with the bending of space-time. I'm sorry.
Does the Curie temperature, if you have the Curie temperature, right, if you go beyond the Curie temperature, is it possible for an object that's beyond the Curie temperature to be magnetized and generate a magnetic field?
Only from an external source.
Right. It is possible. Therefore,
only from an external source.
Therefore, the Curie temperature physics does not mean that it cannot produce a magnetic field.
No, it requires an external source. Which
and the external force is the movement of the gravity causing the heat, causing the movement of the liquid core, causing the electric currents, causing the magnetism. And the point is, this is a perfectly logical explanation. What you're doing is saying there must be some other magic.
No, Miles, you're saying that gravity, which is most accurately described by the theory of relativity by Albert Einstein, not Miles Davis, but Albert Einstein, is a consequence of the curvature of space-time that causes the temperature of the core of the Earth to go to 10,000 degrees, and that's preposterous.
Yes, it would. And you can do measurements very simply. You can do measurements very simply by increasing pressure and measuring the amount of heat generated.
Listen to what you've just said.
It's not difficult.
Listen to what you've just said. I asserted, reading based on Albert Einstein's theory of relativity, that it's gravity is the consequence of the curvature of space-time, and you've accepted that that's what causes the temperature of the core to get to 10,000 degrees Fahrenheit. Miles, it's preposterous.
It's not preposterous.
Okay.
Why is it preposterous?
Because the curvature of space-time doesn't cause temperatures to go to 10,000 degrees in the core of the Earth.
How do you know?
I have to say both of your damn theories are preposterous, and I don't know what the hell to believe because you guys are just rambling now. And
Look, it's very
I feel it is.
straightforward. It's very straightforward. You can show that pressure creates heat. You can show that gravity creates pressure. So,
You can't show that gravity-
so for gravity to create heat is not a great, huge logical jump.
Well, I do have to sort of jump in there and say, like, I have no idea how we measure gravity really. Like, it's partially magnetism, like, but
No, it's not.
well, I mean, where do the poles come from? Like, how is that all generated? Isn't that part of gravity?
No, the poles are the result of the magnetic field. Okay. Yeah, they're caused. They're part of the. Yeah, they're not caused by gravity in the sense directly. Okay.
No, I thought it was more or less.
The magnetic field is caused, and that,
Sorry,
and that
I
gives
sort of
poles.
relate
You
them.
have to have poles if you have a magnetic field. Yeah.
I just relate them closely because I feel like they're both polarized more or less.
Okay.
Well,
I mean, it's to say that gravity is it doesn't. It's not a direct cause, if you like. It is direct, but it's a stage removed.
would there not be an opposite direction of gravity, like as in a polarity?
No. To think of gravity as directional is what people do because we live on the Earth, and therefore everything moves towards the center of the Earth because that is the strongest gravitational effect that we observe. We perceive gravity as making things go down, but there is no real down or up. It's simply towards the center of the Earth, and from our perspective, that means down.
Well, let's go back to the most accurate definition of gravity from Albert Einstein. It's the consequence of the curvature of space-time that makes things go down.
Yes. No, it doesn't. Einstein would never say make things go down.
Well, that's what you've just said. You said it was gravity that makes things go down, and Einstein says that it's
from our perspective, it is not down. It is towards, in our situation, towards the center of the Earth, because the distortion of space-time, the greatest effect on space-time locally is for us is the Earth. Right. If we were closer to another massive object, then it would be towards that massive object.
Okay. Well,
so when the astronauts went to the moon, they weren't dragged down to the surface of the Earth. They went down onto the surface of the moon.
Miles, just to explain to everybody that's watching what space-time is, because I don't know what space-time is.
Space-time is one of those weird, difficult to get your head round concepts, okay? And that's why it's much easier to think for general everyday things. It's much easier to speak of and to think of Newtonian gravity than think in terms of relativity, because it's correct for us.
Space-time is like. Isn't it just a mix of things of like time and like dimensions and sort of
it's
forces?
It's a model that fuses space and the dimension of time, if you want to think of time as being a dimension.
Well, I would have said
into a continuum, and you can't imagine that in your head very easily, because we live in a three-dimension. Time is something that is moving and passing, so we kind of live in the instant, if you like. So we're not experiencing time in the same way that the universe as a whole is experiencing time, if you like. It's not something I find easy to consider, and some of the consequences of considering space-time are surprising. There's all sorts of things to do with the speed of light and stuff that are weird to get your head around. But in terms of physics, when people actually design experiments and make measurements and see what the outcomes are, it works. And that's why general relativity, when it first appeared, a lot of people went, whoa, that can't be right. But over the course of lots and lots of study, everyone went, you know what, this is absolutely brilliant. It explains loads of things we couldn't explain before, and it always works.
Well, that's kind of my point, that just because it explains it, it doesn't prove it, and therefore you accept it as a...
Science doesn't prove anything ever. Do you understand that?
Yes, but what I'm saying is you're citing it to prove that in
No.
this application, you're citing it to prove to be the
I
vehicle or the
I will
cause.
never cite anything to prove anything else.
No, but
Okay?
what
Proof is not proof is the realm of
Man,
mathematicians and lawyers. Okay? What science does is it finds what is the most likely explanation for observations, and over time scientists refine those explanations more and more, and occasionally throw them out because they don't
That-
work.
that isn't the definition of science.
Sorry?
That is not the definition of science.
That's what, no, I didn't say it was a definition of science. I said that's what scientists do. And no scientist will ever claim to have proven completely something.
So
What they do say is that all the evidence that exists is consistent with this explanation of the universe, or this explanation of our observation. So, for example, you know, in germ theory, you know, it's entirely possible that actually it's not bacteria, for example, that cause certain infections, but it's some other thing that's associated with a bacteria. But thus far, we have never found something other than the bacteria that causes those infections, and the explanation seems to be perfectly good, and it works in all situations where a bacteria is the cause.
Sorry to interrupt. I know you guys want to get in about bacteria and stuff. I just want to let you know we've got about 5 minutes left on this stream, just so you're aware.
Okay, and that's what scientists say. That explanation is the best explanation we have for something. They never say we have proved that this is absolutely true, that there is no possibility at all that any of it is wrong.
All right, let me just wrap this up, because I don't know if you heard Miles. Nathan just said there's only 5 minutes left. You came on and said that I had made assertions based on absolutely nothing, and I've presented you the evidence, but specifically the Curie temperature of iron, or Curie temperature in general, and it specifically states that you need an external source, and we've discussed at length what them sources would be, and your position is the convection currents and the Coriolis effect causes them, and I say they're the consequence.
No, I said that gravity
wait
causes them. Don't misrepresent me. You'd love to jump in and you'd love to sum up and tell people what they have said, and you never, ever get it right.
Listen, Miles.
All right, can I jump in? I think it's where gravity comes in and throws everybody off on this magnetic properties. For a guy who's anybody who's in flat Earth, they're going to eliminate gravity and they're going to eliminate the spin. But for my part, when you come back into the electric magnetism, yeah. For my sake of argument, I don't feel like I'm moving, so then I have to eliminate that equation for gravity. So it's a homosexual, by the way.
Let me just carry on, Miles, and you can correct me once I've wrapped it up. We've only got 5 minutes.
I just want to say hello to Curve Water, though. I'm really sorry.
You'll chatter away for 5 minutes.
No, I'll take 2.
Stay up.
Okay.
So you originally came on and said that I made assertions based on absolutely nothing. I presented you evidence of the Curie temperature, which requires that, or which mandates that that metals will lose its magnetism at a certain point. We then had a discussion in detail about what causes the heat that's required, for which you said that it was a little bit of the convection currents, the Coriolis effect, and gravity. And then I showed you that gravity was best described to be the bending of space-time and can't possibly cause what you claim it does. And ultimately, my conclusion point is, I didn't come on making assertions without evidence. I presented you the evidence, and you've presented me scientific theory to explain it but not prove it. And I reject your evidence. I thank you for your time, but you haven't persuaded me that the core is a molten piece of metal at 2,000 degrees that's creating its own its own magnetic field. I'm sorry, okay. Miles.
Fine. Can I sum up now and correct all the lies you just dished out?
Hang on, stop. You just said the word lies. You just said, whoa, you just said the word lies.
Hang on, you had your say.
You said the word lies.
I came on here challenging your description of the heart as not being a muscle, and your description of the human body requiring electricity to function, and explaining that your understanding of the electricity in quotation marks that is used in the human body is very different to electricity that flows along a wire. It is chemically based and is somewhat different. I then we then got on to the discussion about the Earth's magnetic core and how it is caused after that, or how it is produced after that. And I said that you were claiming some external external force to create this. I believe that you think it's some kind of external electromagnetic force. I may have that wrong. It doesn't matter. And I said that you had nothing on which to base that. The only thing that you have produced to support that has been that the Earth's core is believed to be above the Curie temperature of iron, or above the Curie temperature of iron and nickel, because there's some nickel down there as well. And the point that I made to you was that the Curie temperature reaching or exceeding the Curie temperature does not prevent a magnetic field from being produced at all. And I showed exactly what physicists think is the explanation for the magnetic field being produced by a partially molten core of the Earth. I stand by my claim that you have not, that you are basing your assertion that there is some external force on absolutely nothing, because the Curie force does not relate remotely to any external electromagnetic force applying to the Earth. It simply doesn't. It's an observable physical fact which does not prevent magnetic fields from being produced. So
then I guess
there we have it.
I guess we put it out to the chat and see who presented the best evidence. Did I present evidence that persuaded
No, Anthony.
Wait.
People in chat do not decide what the Earth the universe is like. What people in chat do is make their own opinions. What the Earth or the universe is actually like is what they are actually like, and nobody's opinion will change.
But the point is,
Riley, don't you refer to that as appealing to bandwagon fallacy yourself?
It was a debate.
Am I wrong about that?
We didn't get anything achieved, really.
And it was literally the point.
Oh no, that was not a debate, sir.
Well, it was. We both presented.
No, that was not a debate.
Well, what was it then, Curved?
That was you gish galloping, accusing others of gish gallop.
Well, I presented evidence of the Curie temperature.
Okay, it was a very poor debate on your part. How's that? You're discussing things that you don't know anything about. You've read a couple things. You're trying to bring Curie temperature into something that nobody says is a permanent magnet to begin with.
How dishonest of you.
I really don't know what your point is.
How dishonest of you.
And neither do you. And now you're going to call me dishonest.
Yeah, right. It's simply, well, if you think that I was in some way like presenting a poor argument, then I'm sorry. I cannot agree with that assertion to be anything like the truth.
Dude, if you're presenting a poor argument, you're not likely to agree with me, so I wouldn't expect you to. I'll see you in Brussels, sir.
The reality is my arguments were concise, clear, and supported by actual science. Empirical, repeatable, observable science.
It's all supported by
just
misunderstanding.
That limit, and that's it.
I've got to be honest, Curved. I am absolutely flabbergasted that you would assert that my arguments were in any way poor. That's ridiculous.
But you're not expected to realize how poor they are because you don't have any understanding of the subject matter. You read things that you don't understand.
If that's
and then you assert them, and while accusing people, gish gallop when you
if that's your assertion, if that's your position, Curve, you just fell off the bottom of the ladder for me.
Yeah. That's good. That's an improvement.
If that's your position, Curve, you've just fell off the bottom of the ladder for me. I thought that you were intelligent enough to realize that was a coherent, concise, precise, well-evidenced argument.
No, you weren't.
Anthony, you present a single piece of evidence.
And with that, I'm going to say a huge, massive, enormous thank you, first and foremost, to the audience for watching live. And of course, a massive thank you to the panel for making this debate possible. I think you'll all agree Miles and Anthony were both exceptionally good debaters, and they both put exceptionally good arguments forward, regardless of what Curvewater said about it. With that, I'm going to say be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I will see you all in the next video.